Topic 3, we are going to divide rational expressions. And what I want to remind you is with fractions, to divide two fractions, we multiply the first fraction by the reciprocal of the second fraction. So remember that, because that same exact idea is going to come right back, okay? So when we're dividing rational expressions, we have P, Q, R, and S, and we're saying, hey, they're polynomials, as long as Q, R, and S don't equal 0, because remember, you cannot have a 0 in a denominator, okay? So we have this situation where we have P over Q divided by R over S. Well, we convert that to multiplication by saying P over Q times S over R. So then we end up getting PS over QR. So that's basically saying what I just wrote down. When you multiply two fractions or rational expressions, you multiply, or when you divide two fractions or divide two rational expressions, you multiply the first expression or fraction by the reciprocal of the second, okay? So that's exactly what's happening here. It's the same as what we do with just fractions, okay? So the steps that we're going to take here, we convert to multiplication first, okay? And I do say do this first thing because sometimes what happens is you'll see things that you think cancel top to bottom, but they don't because you haven't written it as multiplication. So things cancel top to bottom when you're dealing with multiplication, not division. So convert to multiplication first, then factor everything. Once you factored everything and you're definitely written as multiplication, look for common factors that you can divide out top versus bottom and then multiply across. Okay? So let's see what we have here. So example 3 says find each quotient. So basically just divide. Whoops. So for part A, it looks a little funny. We're going to make sure we write this in fraction form first. So, or rational expression form, I don't know. So we have x squared minus 2x minus 8 all over x squared plus x divided by x plus 2. I'm going to go ahead and just write it as x plus 2 over 1 because I want it to be in fraction form before I do the reciprocal thing, okay? So plain old x plus 2 can easily be written as a fraction by just saying x plus 2 over 1, okay? So then I want to convert to multiplication. So I've got x squared minus 2x minus 8 over x squared plus x. I'm going to convert to multiplication by multiplying by the reciprocal of the second expression. Well, the second expression is x plus 2 over 1, so I'm going to multiply by 1 over x plus 2. That's it. So it's now written as multiplication. And now go ahead and just do that very first thing so you don't forget. Now we want to factor everything. So looking at my first numerator, I have x squared minus 2x minus 8. This is a quadratic trinomial, and luckily the coefficient on the squared term is 1, which means it's like the shortcut factoring. It's pretty straightforward. So we want to find our two binomials. So when I'm dealing with x squared minus 2x minus 8, what I want to do is find factors of -8 that have a sum of -2. So remember, when you're factoring a quadratic trinomial where a is 1, you look for factors of c, the constant, that have a sum of b, the coefficient of x. So factors of -8 could be -8 and 1, or 1 and -8. We could also have -4 and 2, or 4 and -2. So which of those pairs adds up to -2? Okay, well, we can cross out these two. They don't have the right sum. So it comes down to the 4s and the 2s. Well, we want a sum of -2. So in that case, the larger of the two factors needs to be the negative. So -4 plus 2 is -2. So that's going to be our final pair. So we get x minus 4 over x plus 2. Now my first denominator is x squared plus x. So I have a coefficient. I have a common factor of x. So I want to factor out my GCF of x. Well, x squared divided by x is just x. And then x divided by x is 1. And then my second rational expression is just 1 over x plus 2. I don't have to do any factoring there. But I do want to see if I have anything that I could cancel top to bottom or divide out top to bottom. And I do. I see that I have an x plus 2 in my numerator and my denominator. So x plus 2 divided by itself is just 1. Now, on the numerator, I have a 1 and an x minus 4. On the denominator, I have an x and an x plus 1. There's nothing else that'll divide out, so I would just rewrite this as, well, 1 times x minus 4 is just x minus 4. And then the denominator is just going to be x times x plus 1. And you can leave it in this factored form. So that would be your final answer. All right. Second, we have 12 over x squared minus x divided by 4x minus 2 divided by x squared minus 1. Write it as multiplication first thing. Don't even try to factor because you might see common factors that you think will cancel, but they really don't because you haven't written it as multiplication first. So the way we convert this to multiplication is we keep the first rational expression exactly as is, and then we multiply by the reciprocal of the second expression. So the reciprocal is x squared minus 1 all over 4x minus 2. Okay? So first numerator is as good as it's going to get. It's just going to be 12. First denominator, I have a GCF of x. So I want to factor out an x. Well, x squared minus x is x. And negative x divided by x is negative 1. Okay? Now, second numerator is the difference of squares. So we take the square root of x squared, we get x. We take the square root of 1, we get 1. So because we have the difference of squares, remember, it factors as x squared minus b squared. So that's the actual difference of squares. But it factors as a plus b times a minus b. So that just means you take your square roots, you add them, and then you subtract them. So the second numerator is going to be x plus 1, x minus 1. And then let's see, for the second denominator, we have a GCF of 2. So when I factor out the 2, I get 4x divided by 2 is 2x. Negative 2 divided by 2 is negative 1. So let's see what this looks like. Does anything cancel for us? I see two things that'll cancel. I see an x minus 1 that'll cancel. So I have an x minus 1 in the numerator, an x minus 1 in the denominator. Those divide out to just become 1. But I also notice a 12 and a 2. So 12 and 2 both have a common factor of 2. So let's divide out the 2. 2 divided by 2 is 1. 12 divided by 2 is 6. So let's see. For my numerator, I have a 6 factor. I have an x plus 1 factor. My denominator, I have an x factor and a 2x minus 1 factor. So I think everything's as simple as it's going to get. So let's just multiply across. And there you have it. That would be your final answer. And you can certainly leave that in factored form. You don't have to distribute. So that's dividing rational expressions. So honestly, the hard part with multiplying and dividing rational expressions is the factoring. If you haven't practiced your factoring or you're not well versed in factoring, you're going to struggle, okay? So make sure if you're still struggling with factoring, you get the practice and the help that you need. As far as multiplying goes, factor everything, divide out common factors, whatever you have left is your final answer. Division, you convert to multiplication, then you factor everything, cancel common factors, and multiply across. So that's it. Last up, we've got one more video where we'll look at one problem that's kind of mixed multiplication and division.